Hello engineers and welcome back to Civil Nirman. See, in the previous session we have explored the step-by-step process for designing a pipe rack in oil and gas project, right? I have guided you through the initial project kickoff to the quality assurance and final review. We break down for each phase to help you understand how these different engineering disciplines work together to ensure a safe and efficient design. So if you haven't watched that video, I recommend you to go through that particular video first and then start from here. So in the today's session we gonna discuss essential information that will be required for the pipe rack design, or you can say the key inputs from all other disciplines like piping, electrical and instrumentation. See, before commencing the design of a pipe rack, it is very important to concern with the lead piping engineer, electrical and instrument engineers to gather all the following important information before you start your design, right? Whether it's with the available information or with the assumption of the loading, everything you need to take care before you start designing your pipe rack in the stat modeling part. Because see, when you go for the loading part after geometry modeling, the most important point is the loading information that you will require from all this discipline in order to design your pipe rack. So in this session we gonna discuss all the information that you will require from all other disciplines in order to design your pipe racks. So let's get started. So let's start with all the major information that you will require. So I am summarizing all this information here for you. So the first one is the piping information. Next we have electrical and instrumentation information. Third, general consideration, future provision, and the last one is interdisciplinary coordination. Now we will brief about all these points in detail, so let's check it out. So the first one is the piping information that you will require. So in the piping information as well we have following list. So the first one is piping layout and routing. See, this particular information involves general arrangement drawings indicating the proposed routing of all the pipes, including primary, secondary lines and any specific requirements or constraints. Next important point is pipe size and their materials. So the sizes, materials and specifications of pipes to be supported by the rack. Next important point is the pipe load. See, information on the dead loads like weight of pipe, insulation and their contents, live loads, maintenance and thermal expansion loads, wind and seismic load for this particular pipes. Then next important point is pipe stress analysis. See, data regarding the thermal expansion, contraction and any unexpected stress due to the operating condition, right? Similarly, pipe spacing and their clearance. So this is also one of the most important point. See, it requires information related to the clearance between the pipes, between pipes and equipment, and also between pipes and the structural elements in your structural configuration. Then we have pipe support requirements, that means type of supports, guide, anchor and their location along the pipe. Next important point is access requirement. See, any special access requirements for maintenance, operation and emergency situation, all this information we will require in order to develop a complete pipe rack design. Now as you can observe over here, I have added one typical elevation which includes all the components like access way, equipment, their arrangement, spacing between the beams and their clearance, similarly small bore lines, major utility lines, then the location of the trays and their labels, right? Now I'll show you one sample input from the piping discipline how it will look, so that you will get an idea how these inputs are provided. Now see, one important thing is, depending upon the consulting firm or the EPC companies, then this particular inputs may slightly vary in the design format. right? So it may vary in the form of what you can say the input category, but the information which I listed out over here will be same, but it might be in the different design formats. That's what I am conveying. So let's just understand how the piping information will look like, right? So let's understand this through the piping stress input. So let me show you one input from the piping discipline. Now see, this particular is a software configuration from the Caesar software. Now all of you might aware that Caesar is one of the software where piping discipline runs the pipe stress analysis, and based on that particular analysis, piping will give you certain inputs related to the pipe support loads and their information. So how this information look, we will check out this in particular detail. So this is the configuration from the Caesar software. Now as you can observe over here, I have considered one typical 3D sketch. Now see, in most of the multinational firms, all the information related to the 3D modeling is performed in S3D software, where all other disciplines are also working together in order to model every component related to whether it's your cable tray, pipes, everything. So piping discipline will modify their pipes in the same software. Similarly, other disciplines like instrument electrical will also parallelly model their segments in order to track everything which is aligned with the structure discipline as well. So in order to get all the information from this particular category of the 3D, you will able to see each discipline's modeling, and you can identify related to the loading part, related to the modeling part, or any clashes in that particular if it is there, right? So this particular is another 3D sample just for your reference. You can observe there is one pipe rack going here and there is one shelter here, and all these yellow pipelines you can observe. You have this access way. Similarly, you have a lot of cable tray arrangements and equipment arrangement which you can observe over here. Now let me just give you a snap over here. Let's say we have one detailing. So piping, what do they basically do? So if I consider the small portion from this, so in the Caesar software you will get the certain information related to your pipe supports. See, we will support all those pipes on our pipe racks or in the shelter part, so we need to support these pipes with respect to their pipe support category, whether it is anchor, simple support, or the guide support, right? And based on that stress analysis, piping will provide you the detailing related to that particular junction. It will be in the form of the coordinate with respect to east, north, or and the elevation part. Similarly, at that particular location, whatever the category of the support that piping has considered, that support information will be available with respect to the direction and the support tag number, right? So as you can observe over here, we have one screenshot where we have three details. One is the support tagline, means it will start with a certain number to identify that particular support category, right? Then you have the coordinates that is east, north, and its elevation, and the piping loading information, which category of the load based on the support category you have that loading, right? Whether it is anchor, simple support, or the guide support, right? All these category we have already understood, but here just for your understanding I am representing you over here, right? Similarly, so piping will provide you all this detail in the form of the piping layout. You can observe a similar sketch over here. I have taken one small snap just to give you an understanding. Let's say you can observe this pipe is running through here, and you can observe these small tag numbers with respect to each junction. So these are the pipe support numbers, or you can say tags, and with respect to these tags you have these elevations and the load categories. So they will provide you all this information in the bunch of a PDF form or in the bunch of table form, where you have all this information and you can track based on your S3D modeling and the loading information which is provided by the piping. Now let's understand how this information looks like, right? Now see, as I told you, based on the consulting EPC firms practice, every firm have their own standards. So depending upon that particular loading information may be slightly vary, okay, but majority of the time it will be same. So they will give you from the Caesar pipe stress analysis. After the analysis from the Caesar software, they will provide you input something like this. You can see this particular is the node number that you can identify that particular as a pipe support number or tag number. So in that software it will be in the form of node number. Then you have restraint type, which category of support it is. See, as it's a raised support, it has the vertical reaction, then it has the pipe support number. Then you have fx, fy, fz, their coordinates, north elevation and easting, pipe diameter, and additional information which is required to identify the pipe support. Now you can observe that for this particular each node or these pipe support segment, you have all these different categories of the loading information available from the piping input. So it can be an empty load, operating load, then wind load and snow load. Similarly, if I talk about the rest and anchor guide support, you can observe based on the rest and anchor guide, see all these three directional conditions are restrained, and you have the PS number, then you have the load category. Now see, piping will give you all the identification related to all the node. Let's say the first one, WNC, is the empty load of the pipe. Then you have the maximum operating load, normal operating load without friction, maximum and minimum. Then you have wind load, snow load. You can have the surge load as well depending upon the piping analysis. The next one is the rest and guide support. So this is the information from the piping that will be provided in terms of the category, right? And based on this information, you need to implement all these loadings in your pipe rack, right? So either you usually what you do once you complete your modeling part, if you don't have the loading information available from the piping, then you can utilize the PIP guidelines to input all those piping loads in your STAT model, or else you need to refer the accurate piping load input as I told you, right? Like this, you need to enter each load category in your STAT model. So that was the piping input part. Now let's switch to the next part. Next information that we have is related to your category of the loads, right? So as I told you, depending upon the category of the support, in the case of let's say thermal load, you have friction load, anchor loads, cross guide loads, and guide restraint loads. So these are the category of the support which I shown you in the previous slide based on the loading information: rest support, anchor support, cross guide, and guide restraint. And based on that, based on the Caesar input, piping will provide you this particular category of the loading information that you will require in order to analyze your structure accurately, right? So if you have those particular loadings, you need to implement in your STAT model, or else if the project is in the initial phase, then based on the PIP guidelines, based on the assumption or based on the provided piping information, you need to implement your pipe loads. Next important point is electrical and instrumentation information. So in this particular as well, we have following information that you will require. The first one is cable tray and conduit routing. So the way similar we have the piping information, in the same manner we have this cable tray and conduit routing information as well, where this particular disciplines will give you idea about the cable tray routing in your shelter or pipe racks, and the loading information related to that particular part. So loading and routing of cable trays, conduits, and electrical or instrumentation cables that will be supported by the pipe rack. Then the load information such as lighting, instrumentation panels, and motor control centers that may be mounted or near the pipe rack. Then important point is clearance requirement. See, required clearance between the electrical and instrumentation cables and piping to avoid interference or hazards. Now let me just give you a brief on this. If I show you a schematic sketch of this particular portion, see, here. As you can observe over here, let me just switch to this. As you can observe over here, we have this particular cable tray going downside from here. Similarly, there are lot others routes available for the pipe rack. If I show you this another one, you can observe that 3 different cable trays are running. So see, these 1 and 2, the same cable trays are routing at the same level, one beneath the other one, right? And this one is slightly outside of this particular structural framework, and you can see that this cable tray is supported with your cantilever structural member, right? So this is one tray going downside, and these two trays are running parallelly at the same location, right? So all this information you will get in your 3D modeling. You need to review that based on this particular segment. It will be a condition something like this, right? So you need to identify this clearance, center to center distance between the tray elements, whatever the space they required in order to put the cables over here, or in order to operate for the installation part, or whatever the cantilever support requirement they have. All this information you need to discuss with this particular disciplines in order to work out and start providing the loading information or to freeze your structural geometry. Now let me just give you a quick highlight on the cable tray part. So here I have one of the sample vendor file where vendor has provided all the data information related to the cable tray installation, means what will be the height, length requirement, everything. Also the routing requirement, how they will provide the bends, whatever the additional support they will require at the turnings and at the bends, right? So all this information will be available from the cable tray vendors, and you need to coordinate all this information with your electrical and instrumentation discipline. They will provide you the data, design data based on the vendor, based on once the vendor is finalized for your cable tray installation, and they will guide you further based on the details supplier will be provided. So this is one of the highlight from the cable tray inputs that you will require, right? So this is the information: clearance requirement clearance between the electrical and instrument cable trays, and piping to avoid the interface or hazards. Then earthing and bonding, means requirement for earthing, grounding and bonding of electrical systems on the pipe rack. Then instrumentation and control valves. See, location and specification of, let me switch to the main modeling part over here. Instrumentation and control valves. See, in this particular, locations and specifications of any instrument control valves, junction boxes and related equipment to be mounted on the pipe rack, you need to identify and ask for the loading information if such information is missing. Then access and safety, so requirement for access to electrical and instrumentation equipment for the maintenance and safety, including the walkways, platforms and ladders, right? Next important point that we have is the general consideration. See, in the general consideration, this will vary project to project basis. It can be the environmental conditions, data on specific environmental conditions such as wind speed, seismic activity, temperature variations and corrosive environments if there are. Then next important point is regularity and safety standards. So it must complies with the applicable codes, standards and regulations based on the country's code specification where you are designing your structure, right? I can guide you for the certain standard like ASME, ANSI or OSHA. Then next important point is construction and maintenance requirement. See, information on constructability, installation sequences and maintenance need is one of the major important point and need to consider. Next important point is the future expansion. See, any provision for future expansion, additional loads or modifications that maybe impact the pipe rack design that you need to consider, right? Similarly, next important point is interdisciplinary coordination. See, ensuring the alignment with the civil, structure, mechanical and process engineering requirements to avoid any clashes and ensure an integrated design approach. So consulting with both the lead piping engineer, electrical and instrumentation engineers early in the design phase ensure that the pipe rack design will be adequately meet all the functional, safety and regularity requirements, right? So these are important points that you need to consider before commencing your pipe rack design. If any data is missing, you need to concern with all these disciplines in order to gather all the design data related information. So I hope this particular information gives you more insight how the projects are exactly working on the field and what category of the data you will require in order to ensure all these categories. Stay tuned for next session and remember, don't just learn software, learn concepts.